Good morning, Math 1 students. This is Mr. Flynn. This is your video lesson, your first one of two of them. This will be on what's called the independent and the dependent variables. And this deals with a lot with graphing that we're going to do with the entire unit, okay? It says, consider the two quantities that are changing in each relationship. Circle the independent quantity and underline the dependent quantity. So it says a number of movie tickets purchased and the total cost. Well, we have to understand what independent and dependent means. If you think to yourself, are you independent or are you dependent? The reality is the independent variable is the one that it doesn't matter. It's on its own. It's going to happen. The dependent variable will only happen if the independent happens, and it'll change as the independent changes. So a good example is this one. Remember, we're going to circle the independent. We're going to underline the dependent. So the independent quantity in the first example, the independent is the number of movie tickets purchased, because we're going to purchase them. And that's going to change. That's going to affect the total cost. If we purchase one, it might cost $10, right? If we purchase two, now the total cost is $2. So as we purchase the movie tickets, which is the independent, it changes the total cost. Okay? Now the next one's a little harder. It's hard to see at times, but it says the number of eggs used and the number of cakes baked. Well, we have to understand that used means that it was done afterwards, okay? So if we know the number of cakes we bake, then we know how many eggs we used. So the number of cakes baked is the independent. All right? Some people may say, well, we can't bake a cake unless we have eggs. Well, they're not asking that. They're talking about the number of eggs that were used, like in past tense. Okay? So now, the third example, the number of students in attendance at school and the number of lunches served. Well, the number of lunches served is always going to be dependent on how many students are in attendance. Okay? So again, independent we circle, dependent we underline. So look at the last one, or not the last one, the number of hours driven and the number of miles to a vacation destination. All right? So this one I'm going to kind of help you with, and we're going to work with this one quite a bit. But the number of hours we drive is always going to be the independent. Okay? Time, almost always independent. And then that'll tell us how far or how many miles to our destination. Okay? So keeping that in mind, a number of minutes in a swimming pool is filled, a swimming pool is filled with water, and the number of gallons of water in the swimming pool. So they're filling a swimming pool. Well, what we just talked about, the number of minutes we fill it, that's independent. The number of gallons we put in is dependent on how long we fill the pool. Okay? So that's your independent dependent start. Now it gets a little easier as we move along because they're going to have a long word problem, and all I want is the independent variable and the dependent. Please remember, time will be your independent. Okay? Candace is as a building manager for the Crowley Enterprise office building. One of her responsibilities is cleaning the office building's 200-gallon aquarium. For cleaning, she must remove the fish from the aquarium and drain the water. The water drains at a constant rate of 10 gallons per minute. So now we have draining of gallons and we have minutes. Those are our two quantities. right? And we just talked about the independent is going to be time, but we have to say it like this: time in minutes. The dependent quantity is gallons. Okay? Baton twirling. Again, we're going to see time come up here. Jill is a drum major for the Altadena High School Marching Band. For the final of the halftime performance, Jill tosses her baton in the air so that it reaches a maximum height of 22 feet. This gives Jill 2 seconds to twirl around twice and catch the baton when it comes back down. So we're talking about a quantity of height, and we're talking about seconds. All right? So which one is the time? Right, it's the seconds. So it's time in seconds as the independent quantity, and the dependent is the 22 feet. Or we should just say feet. Okay? Now there's a little typo on this next one, and I'll show it to you. You can change it. Let's make it a little bigger so we can see. The number of guests at a ski resort on any given day is related to the day's high temperature. If the high temperature is, and this should be negative 20 degrees or below, no one comes to the resort. As the temperature increases, so does the number of guests. As the temperature reaches 0 Fahrenheit and increases to the single digits, the number of guests soars. If the temperature is 10 degrees or higher, the ski resort is at full capacity with 400 guests. So, our quantities are temperature, and our other quantity is number of guests, right? So, what's independent? What's happening on its own? It's the temperature, right? As the temperature goes up, more people show up. As the temperature goes down, less people show up. So the dependent quantity is the number of guests. All right. Now, here's where it gets, I think, the easiest, and I don't want to see any mistakes on this. Okay. We're going to come back up here just really quick. I'm going to put here the x value on a graph is always going to be the independent, and the y value will always be the dependent. Ooh. Okay, so now you have to think about, and I'll draw it over here, if I have a graph, okay, I can draw it better than that. If I have a graph and a graph, right? This is the x-axis and this is the y-axis. So this counts the x's in the positive. This counts the x's in the negative, right? This counts the y's in the positive, and these counts the y's in the negative. Remember that this little point in the middle is called the origin. And that's the coordinate 0, 0. That means where the x is 0 and the y is 0. So if you look at 0, 0, the first number is the x, the second number is the y. Okay? So we just did a very quick review of a coordinate graph, how it looks, how we write the coordinate, and we now connected it to the independent and dependent. So we can now graph those. Okay. One other thing I'm going to do with graphing is I'll do another graph here real quick. We can do it off to the side. So here's the x and y. All right. So here's our x. Here's our y. Now we're going to talk about the quadrants. If you notice, there's 4 quadrants. 1 quadrant, 2, 3, 4. And that's how we number them. This is quadrant 1. We use Roman numerals. Quadrant 2. Quadrant 3, and quadrant 4. We use Roman numerals to denote them. All right, but it goes this way. This is the positive of the x and the positive of the y, and it rotates around. So, with that said, it says Madison enjoys bicycling for exercise. Each Saturday, she likes to bike. She bikes a course she has mapped out around her town. She averages a speed of 12 miles per hour. So we're talking about miles and time in hours. So the independent, I keep doing that. Let me do this again. I apologize. The independent, that's going to be our time in hours. Our dependent is, I'm spelling everything wrong this morning, boys and girls. D-E-P-E-N-D-E-N-T. That's going to be miles, right? Because we know that time is always going to be independent. And we know from what we set up here that the x is the independent and the y is the dependent. So now we're going to label the axes, okay? So what we're going to do down here for the x axis, we're going to say time in hours. And for the y-axis up here, we're going to say miles. Okay? Pretty simple. So then down here, Marcus throws a football straight up into the air. It reaches a maximum height of 20 feet, and it descends back down to the ground. Now, what they didn't give you, and I'll help you out here, is the time. It could be in seconds, which I think it is. All right, that's going to be our independent. Our dependent is going to be height. Because if you throw it up, it can stay up in the air for an amount of time, but after a while it has to come back down. Notice the graph is like he threw it up and then it came back down. So the x will be time in seconds, and the y is the height. This is called labeling the axis, okay? So what we have just done, I think we're done with all this here, is we talked about which one is the independent and dependent. Remember, the independent stands alone, it's going to happen, but the dependent is the variable that changes because the independent changes. So if you are, you're buying a dozen eggs, right? If you buy 1 dozen, you get 12. If you buy another dozen, you get 2. So the more you buy, it depends on the total cost or the total number of eggs you get, right? So there's an independent quantity, and then there's a dependent quantity. Then we did it in word problems and kind of did the same thing, just pulled out the independent and dependent. Then when we got down here, we had a graph, and we had to talk about that graph, and we had to remember that the x is always the independent quantity, and the y value will always be the dependent quantity, all right? And then we talked about the quadrants, all right? I hope that helps. Now, what I'm going to do is go to the classwork here. Oh, wrong one. I'm going to go to plotting points. What we're going to do here is there are 6 problems, and I want to plot the points. I want you to plot them and label. Okay? So notice where number 1 is, or number 1 says A is 1, -2. So that means the x value is 1, the y value is -2. Always start at the origin in the middle, and then from here, let's make this big so we can kind of see how it works. We start here, we go 1 in the x, now we're here. And then we go 2 in the negative y direction. And so we end up here. This is all we put. So really, I can take this stuff out and just leave the point. But to label it, we have to put the letter on it. The letter A, because that's what the letter is, okay? B is 9, -5, right? So we start in the middle. We go 9 in the X direction positive. We're here. And we just stop. And now we're going to go -5. 1, 2, 3, 4, 5 here in the X direction. So we're going to have this point here. Or let me say this again. We're going to go We're going to go 9 in the positive X, and then we're going to go 5 in the negative Y direction. And we put our point on there. We don't need those here. We just have to put the point, and remember that's point B. Okay? So C, we're going to go over, start at 0, go over 8 in the positive X, up 4 in the positive Y, put our point on. That's going to be C. Again, I don't need this stuff, but it helps me see it. D says 4 in the positive X, and then 0 in the Y, which is right there. We just stay right there. All right? And so that is point D. And then E is 3, 2. So I'm going to go 3 in the X, 2 in the Y, put my point, and that's point E. All right. Now, the answer key is at the bottom. All right, you can always check them. There are 6 to do. I want you plotting each point and labeling each point. This is going to be submitted. You will submit, all right, to turn in. So you actually have 2 assignments to turn in, all right? You have the evaluating one that I did that you'll do next, and you have this one. Do not submit your notes. Don't submit this. This you save to your drive. Well, sorry about that. You save it to your drive, okay?